Um, Hello. So today we are going to start with Unit 2, but before that, let us quickly revise few of the concepts we learned in the previous grade. So we know that atom is the smallest particle which make up matter. Now, matter is anything which has mass and which has volume. So anything that you can feel around you is made of the smallest particle called atom. Now, this concept that any matter is made of smallest particle atom was proposed by John Dalton, and he coined this term atom from the Greek word atomos, which means indivisible. So, initially, he proposed that atoms are indivisible particle. They are the smallest particle. But later, when Sir J.J. Thomson discovered the negatively charged particles, which are now known as electrons, and later with the discovery of protons and neutrons, it is now uh, it is now proved that atom has subatomic particles, or it has still smaller particles, which are the electrons, protons, and the neutrons. So the the electrons, they are represented by E in lowercase, and they carry a unit negative charge. So one electron has a charge of -1 unit, and they are present in the shells or the orbits around the nucleus. So they keep spinning around the nucleus in their orbits or the shells. The protons, represented by P in the lowercase, are actually the positively charged particle, and one proton is said to have +1 unit of charge, and the neutrons are the neutral particles. They carry no charge. The protons and the neutrons present inside the nucleus are together known as nucleons. So they are present in the nucleus. So as per the Rutherford's and Bohr's, which was later modified by Niels Bohr's model of atom, there at the center of an atom, there is a positive body called nucleus, which has got all the protons and neutrons enclosed in it. Because of that, nucleus has got a positive charge. Then outside the nucleus are the orbits or the shells. They are also known as the energy levels, or we call them as shells, or we call them as orbits. Okay, so electrons are present in these shells, they are distributed in these shells, and the protons and the neutrons, they are enclosed inside the nucleus, right? Now, atom as a whole, though it has got the charged particles, electrons and protons, but atom is neutral. Atom does not have any charge. It's because the total number of protons which are present inside the nucleus of an atom are equal to the total number of electrons which are present outside the nucleus in the orbits. That means the total positive charge is balanced by the total negative charge present in an atom, and as a result, atom is neutral. Now, we know that there are approximately 118 elements. Elements are, we call them as the pure substances. So if I say gold, that's an element, right? And this element is made of all gold atoms. Okay. The same way, if you talk about aluminium or zinc or copper, all those are elements. Even oxygen is an element which is made of all oxygen atoms. So every element is represented by a symbol in the periodic table. So because chemistry is the science of symbols, so we represent all the elements with the help of a symbol. So now at present you are supposed to learn the symbols of first 20 elements present in the periodic table. So whenever you look at the periodic table, say for example, the first member of the periodic table is hydrogen, and hydrogen has a symbol H. So the symbols are taken from their, for most of the elements, the symbols are taken as the first alphabet of their English name. And along with the symbol, we usually notice two numbers written. For hydrogen, exceptionally, it is the same one, but let us see about helium. Now, helium also has first alphabet H, and in order to avoid any confusion between hydrogen and helium, this time the symbol for helium is He, wherein the first alphabet is written in the uppercase and the second one is written in the lowercase. And the two numbers written here are 2 and 4. Now, what does these number represent? Always remember that the smaller number written with the symbol is representing the atomic number of the element, and the bigger number is representing the mass number of the element. So the atomic number tells us how many protons are present in the nucleus. So it tells us about the number of protons present inside the nucleus, and the mass number tells us about the number of protons plus the number of neutrons. So it's the sum total of the nucleons present in the nucleus. This is why the mass number is a bigger number. So the mass number tells us, or we also call it as atomic mass, and it tells us about the number of protons and the number of plus the number of neutrons, and the atomic number tells us about the the number of protons present in the nucleus. So, uh, and because as I said, the atom is neutral, so atomic number also tells us how many electrons are present. So because atom is neutral, so the number of protons are always equal to the number of electrons. So we can say the atomic number tells us how many electrons are present in an atom of that particular element, right? Okay. So for example, if we take again the example of helium with atomic number 2 and the mass number 4. So its atomic number is 2, which indicates that the number of protons present in the nucleus of helium is 2, and the number of neutrons plus protons present in the nucleus is 4. Now, because the protons are always equal to the number of electrons, so the number of electrons present outside the nucleus in their orbits are also 2. While the number of neutrons you can calculate by subtracting the atomic mass and the atomic number. So for helium, it has 2 neutrons, 2 protons, and 2 electrons. Let's take another example. For example, there's an element called sodium. Now, sodium does not have the symbol S because its symbol comes from its more popular name, which was its Latin name, natrium. This is why, and in English, it is known as sodium. So, for some elements, their symbol comes from their Latin name. So, natrium is the Latin name for sodium. Now, so whenever you'll see sodium in periodic table, you'll see two numbers written with it, 11 and 23. So as I said, the smaller number represents the atomic number. That means the atomic number for sodium is 11. Now, when the atomic number is 11, that means the number of protons present in the nucleus of sodium is 11. The number of uh, electrons present outside the nucleus is also 11 because protons and electrons are always equal, and the number of neutrons is atomic mass minus atomic number, that is 12. So the nucleus of sodium atom has 11 protons, 12 neutrons, and outside the nucleus are 11 electrons distributed in their orbits. So likewise, you can practice finding out the subatomic particles for elements with atomic number 1, which is hydrogen, till atomic number 20, which is calcium. So learn the symbols of the elements and try finding out their protons, neutrons, and electrons. That's all for this class. Thank